The current is flowing here. So here we have I, which is the current which is flowing. Is that okay? Are you concentrating here or not? Here, here, it is important here. Okay. So we know that the current after coming here, it branches out. It is branching out. So some current will go here, some current will come here, and some current will come here. Think of it once again in terms of water. Okay?
Will be distributed in both
Yes.
R1, R2.
Yes, yes. So we have got current. Some part of current is going here. Some part of the current is coming here. Some part of the current is coming here. Okay. Is it the same current which is branching now? Do you think it is the same amount which is going in each of these different branches? No. How is it dependent? It depends upon the type of R that you are having. Okay. For example, you are having resistance. Maybe it is a bulb. Maybe it is a heater. Okay. Maybe it is an AC. Will they all draw the same current? Definitely not. Okay, so each one of them draws a different amount of current. Therefore, the current which is flowing through each one of these branches are entirely different. Okay, so here, in order to measure, how do we measure? Is once again you can have an ammeter. Okay, for each one of them, we have an ammeter reading, and we find that I1, I2, and I3. What is I? I is nothing but the current. So the current flowing through each one of these branches obviously is going to be different. Have you all followed? In contrast, what happens to RS? What happens to I there? See I there.
I is same and I is different.
Yes, here I is the same. It is the same I. It is the same current which is flowing through all the three resistors. Okay, but here what is happening? It is I. That is the total I which is flowing. That is the total current which is flowing here is getting distributed amongst all the branches as I1 and I2 and I3. Is that okay? Have you all followed? Okay. And this you can actually do the measurement by setting up an experiment. So we are going to take the measurement of the ammeter here, which is going to give you the total current. Okay. And we know what is the current here, what is the current here and here. That is I1, I2 and I3. So therefore I is nothing but a summation of all the current here. Okay. Next we want to find out what happens to V. Is the potential difference different for each one of them? How do we find out? Once again, maybe we can have a voltmeter here. So I'm going to connect it to the voltmeter. Okay. Right? So this is your voltmeter. Show that the positive and negative because this part of it is connected to the positive end of the cell. Right? What does a voltmeter do? What does it measure? Voltage. That is the potential difference. Okay? So we are measuring the voltage. And when you see the voltage, you find that the voltage across all the three of them. You see how we are connecting it across this point, which we can call it as X, and across this point, which we are calling it as Y, or you can call it as AB or whatever it is. So what are this X and Y? This is a common point where we are connecting all the three resistors. Okay. What did we find here? We find that the voltage is the same, whether it is across this, or this, or this, it's going to show you the same voltage or the same potential difference. Is that okay? Here, what did we find? What is same here? Is the current same? Current is the same. Here, current is different. Okay, now look at the potential difference. What about the potential difference there? It was the same. Okay, potential difference across each one of them is same. How can we find out? Is suppose we are having one here, voltage being here. Okay, this is going to be the same. Because why? Because we have seen that resistors, all the
Now,
three
if the
resistors.
current is same, then the potential will be different.
Which one? Current is the same. I is the same
But
across
the whole
total voltage. It is a total voltage, which is going to be a summation of V1, V2, and V3. Here it is not that, no? It is only V. That is how we are deriving this. RS is equal to R1 plus R2 plus R2. How did we get? V is equal to V1 plus V2 plus V3. We have used Ohm's law, and that is how we got this particular formula. Did you all understand? Is it clear to now? Okay. Now I want you to look at your textbook. There are two diagrams given in the textbook. Both of them are for parallel, only calculus. One is on page number 182. This diagram. Page number 182, resistors which are connected in parallel. If you see the diagram which we have put up there, it is the same diagram. Ammeter, you can either connect it in series here. Look at the board. Ammeter can be connected in series. We can connect it here, we can connect here, we can put it here, anywhere. It is perfect here. See how they are connected, it is in series. Is that okay? You can also put a key switched in order to make sure that the current can be switched on and switched off. Now the same diagram is also given here. Go to the next page. Go to the next page, resistance in parallel. Okay, this is figure 11.10. Put a tick mark. What do we see here? Here, this diagram is the same. Put a tick mark. That is for RP. Just write down as RP. This thing, 185. In my book, it is 185. Okay. Come to the next page. Did you see this part? Did you see this part here? It is nothing but this part which is explained to us in detail. That is also RP. They have not shown the entire circuit, but what they have shown is only the three resistors which are connected in parallel. So if you take V, that is your voltage across R1, across R2 or across R3, it is going to be the same. Come on, right? Start writing in your notebook a few points for you to know. Resistors in parallel. Okay. When the three resistors are connected together,
The
between
three resistors.
are connected together between points I have taken the letter here x and y. Okay, between x and y. This is with reference to the figure I'm telling you. Between x and y, between points x and y, then the resistors are said to be in parallel. Between points x and y, then the three resistors are said to be connected in parallel. Is it clear? Yes. Okay. Shall we proceed? Okay. Next point. The total current I. The total current I is equal to the sum of the separate currents in each branch of the combination. Next point. What about V? What do we talk about V? Voltage, is it the same or is it different across each one?
Different.
It is the same. Whatever is here, it is opposite. वहाँ क्या है? It is opposite. You remember? Here it was V1 plus V2 plus V3. Here it is V is a constant. Next point we'll write potential difference across each one of them. Potential difference across each resistor is the same. Okay, right? Now what is it? Remember Ohm's law? What is Ohm's law? V is equal to I R. Maybe Ohm's law. Okay, V is equal to I into R. What about I? I is equal to, come on,
V by R.
V by R.
V upon R. So I'm going to substitute here. Okay, so when you substitute V upon R, now since we are talking about parallel, I put it as P is equal to, for this I, once again V upon R1 plus V upon R2. Okay, and here I write it as V upon R3. Should we write it as V1, V2 and V3? Why we did not write it? Yes, because V is the same. Is that okay? Okay, so obviously when you write it down, this you can take it outside the bracket and write it down this way. Correct? V gets cancelled out, that's a common factor. And therefore, what do we get? 1 upon RP is equal to 1 upon, take it up. Okay. From here, we have already written that the total current in the combination of parallel is equal to the sum of the total currents in each one of the connections. Okay? By using Ohm's law. Come on, write it down. By using Ohm's law, we are substituting V is equal to IR, I is equal to V upon R. Okay, so we are substituting here for each one of them. Why did we put RP? Because P is for parallel. P is parallel. B obviously is common here. We are taking out V outside the bracket and therefore it gets cancelled. So what we are having now is a formula where we can use the equivalent resistors connected in parallel. Do we understand?
RP is equal to R1 plus R2 plus R3.
Will it be R1 plus R2 plus R3? Can I write RP is equal to R1 plus R2 plus R3? No, we cannot write. This is the reciprocal of the resistance parallel or the equivalent resistance is equal to the sum of the reciprocal of the individual resistance. Why do we use the word reciprocal? What is the reciprocal of, let us say, 10? 1 by 10. Okay. Understood now. What is 1 by 10? It is 0.1.
Ma'am, if like 1 by 10 is equal to 1 by 2 plus 1 by 5, so we can write it like 10 is equal to.
Will it be like that? That is what I am trying to tell you. When you are talking, I'll give you an example. We'll do a sum, then you will realize. It is not RS, just as where I think RS is equal to R1 plus R2 plus R3. It is not that. We are talking about the reciprocal of, it is not the same as 10. Is 10 the same as 1 upon 10? No. How much is 1 upon 10? It is 0.1. So the values are definitely going to be different. Did you understand? 1 upon 10 plus 1 upon 5 plus 1 upon 3. Will it be the same as 10 plus 5 plus 3? No. You have to do it as 1 upon 10 plus 1 upon 5 plus 1 upon 3. So therefore, this value is going to be very, very small. So what is the final conclusion that you will see? Is your RP, okay, that is the equivalent resistor in parallel, will be small, will be much smaller than any one of these. Do you understand? I'll give you a sum. When we do that sum, you will be able to understand. Take down the final statement. Therefore, the reciprocal of the equivalent resistance therefore, the reciprocal of the equivalent resistance of a group of resistance joined in parallel, reciprocal, the reciprocal of the equivalent resistance of a group of resistors connected in parallel, group of resistors connected in parallel is equal to the sum of the reciprocal of the individual resistance. Okay, come to your textbook. Right, I'm on this page. We have come till here. Applying Ohm's law, V is equal to IR. Did all of you get it? Yes? Okay. So from equations there, we get V upon Rp is equal to V upon R1 plus V upon R2 plus V upon Rp, which is finally equal to 1 upon Rp. And just below that, we have our definition, which I have given you. Put a tick mark there. Thus, we may conclude. Did you see the paragraph? Put a tick mark, underline, whatever it is. Yes, yes. Is that okay? So that is your definition. Now let's see an actual situation. Let me say 5, 10 and 30. In this case, I have given you 3, 5, 10 and 30. Let's say we have taken 5, 10 and 30. Take down this question. Now, help you to understand it better. Come on, write down. Come here. Come. Come. Take your bag, books, everything. Come here. Alright, fast. Okay, this is my question. Okay, we have 3 resistors measuring 5, 10 and 30. Now my question is find RS and RP. Is it going to be the same? Okay, let's see. Right? Come on, do yourself. If you want to find out RS, you're going to use this formula.
Where is the light on?
One month, something which is making so much noise. Yeah, that is good. Okay, Shiva, now what can we do? So how will we find out RS? Substitute here RS.
45.
Obviously, 30 plus 10, 40, 40 is 45. So RS we have already found out that it is 45. Is that correct? Now if you want to find out, sorry, is equal to minus. Okay, is equal to, right? Now we have to find out RP. For finding out RP, we are going to use this formula. So how do we do it? Yes. So it is 1 upon RP, which is equal to 1 upon 5 plus 1 upon 10.
Equal to 1 by 3.
Find LCM. Find out the LCM. Come on. Voice quickly.
1 by 3.
Show me the working. Working is done. LCM is 30. 6 plus 3 plus 1. This is 1 upon RP. This is 60, right? 30, sorry.
1 by 3. 1 by 3.
Got it? No.
1 by 3.
Did everyone get it as 1 by 3?
Yes, ma'am.
Okay. Is this the answer? Is 1 by 3 the answer? No. What should we find out? Yes. So your RP will be how much? 3 inverted. You just have to invert. So
That's
therefore,
what I was saying, like 1 by 10, if I 1 by 10 is equal to 1 by 2, would be the answer.
so is the answer same? Is it 45 days?
No.
Prashita, did you understand? This reciprocal or therefore the answer is going to be different. Okay? If it is the same thing, we would have used this, isn't it? Now, what did we notice here? Your final answer is 3. Now, RP is going to be more than or is it going to be less than the individual one? It is going to be less than. So, R1, R2 or even R3, if you take any one of them, this will be, RP will be less than the individual resistors. Did you understand? Make a point there. Because when you write down, you must also cross check your answer whether it is correct or not. So when do you think RP is going to be used? When do we use such type of connections? When we want to reduce the resistance. Have you followed? When we want to reduce the resistance, then we have got all these connected in parallel. But there are some cases when you want to increase the resistance, that is when we are going to be connecting them in series. Is that okay? What do you think is happening at home for domestic supply? Okay, let's say you have got a TV, you got a tube light, and there is a I'm talking about a geyser or whatever it is. Suppose in this case, now pay attention, pay attention. I have a TV and I have a bulb, and let us say I've got an oven or a geyser or whatever it is. Let us say all of them are connected in series. Is this a good idea? Will all of them draw the same current? No, definitely no. We know that oven is going to, yeah, obviously, heating capacity is more, so it's going to draw so much of current. So it's not a good idea to connect each one of them in series because each one of the appliances has got a different resistance and it requires a different amount of current. Second thing, suppose let's say the TV has found out. Let us say, what will happen to bulb and oven? What will happen? They will work. What's happening here? The current is the same. If there's no current here, bulb and oven also will not get the current. So they will also stop working. So it's a very bad idea to connect different appliances in series. It is never connected. So how do we connect? Sorry?
That's why LCD is used.
No, that is different. That is everything. I'm talking about the connection now. Okay? So what you're talking about is electric circuit. Okay, that is a fuse. So we'll talk about that a little later. Did you understand why we have never any connections made in series for home appliances? So let's see here. Suppose I'm having the same thing. I have taken the TV here, I've taken the bulb, and let us say I've taken the oven here. What's happening to the current? The current passes still here. At this position, it is branching out. Did you see that? So there is some current going here, some of them are going here, depending upon the resistance. If the resistance is low, what happens to the current? The current will be more. Remember? Yes, resistance. If there's too much of resistance, obviously the current will not flow through. If the resistance is low, then of course the current will flow. So each one of these appliances will draw the current as per whatever resistance is present. Let's say in that case, suppose the TV is not working. What will happen to the bulb and the oven? It will work. So the bulb will work, the oven will also work. So how is the electrical connections done at domestic supply? It's always in parallel. Okay, what is the advantage? So that even if something does not work, all other appliances are not getting affected. And second most important point is, each one of them requires a little different amount of current to flow through, and that of course advantage you will get by connecting them in parallel. Third advantage is you can reduce, okay, the resistance in the series if they are connected in parallel. So you got 3 points. Got it? Tell me what are the 3 points.
No. Appliances should not be connected in series.
That's my question. Why should they not be connected in series?
So that
Answer.
they all work separately.
Okay.
Even if one is not working, others are able to function.
Okay. What else?
So
Yeah.
the more the resistivity, the less the current.
Correct. What else? What else? When is the RP utilized? In order to decrease the resistance of the entire combination. Is that okay? Look at your textbook here. This paragraph. Page number 187, the last paragraph. Have you read? Okay. Read. We have seen that.
We have seen that in a series circuit, the current is constant throughout the electric circuit.
Underline. Now I want you to remember whatever points we have discussed and underline those words. Okay, what did we see? Current is constant. Underline that.
Thus, it is obviously impracticable to connect
Impracticable.
an electric bulb and an electric heater in series because they need currents of widely different values to operate properly.
Underline that word. They require current of a widely different value. Next.
Another major disadvantage of a series circuit is that when one component fails, the circuit is broken and none of the components works.
1 minute. What did you do now?
I
Oh, you switch it on and you keep it down. Keep the mouse there. And don't touch it.
Another major disadvantage.
Disadvantage of series.
If you have used fairy lights to decorate buildings on festivals, on marriage, celebrations, etc., you might have seen electricians spending a lot of time and trouble locating the replacing the dead bulb. Each has to be tested to find which has fused or gone. On the other hand, a parallel circuit divides the current through the electrical gadgets. The total
What happens in parallel? Underline that statement. Parallel circuit divides the current through the electrical gadgets. There.
The total resistance in a parallel circuit is decreased.
Underline. It is decreased. So these are the words that you have to look out for when you write the answer. Have you followed it? Don't write as one common statement saying that you cannot use it in series. What are the things? Okay, why? All these are the points that you must remember to write.
This is helpful, particularly when each gadget has different resistance and requires different current to operate properly.
Okay, so I've just taken 3 examples where we have got 3 different gadgets which is operating on 3 different quantities of current or the magnitude of current. Put a Q there. Okay, put a tick mark because that is one of the questions that you might be asking. Will be asked about this. Okay, that's your application type of a question. Now that we have completed about series and parallel, you should be able to do a couple of problems now. This is okay for us. We have seen that the answer for RS will not be the same as the answer for RP. Have you followed? You find what do you find here? RS in this particular case. See, that's why I told you not to sit there because again you're chatting. Please don't. And I don't like, first of all, I don't like to be distracted in the class.
Finding out this makes
Don't. Listen to me. Okay, RS. RS is always more than the individual resistors. What is happening here? What is happening to RP? RP is always less than each one of the resistors. So when do we use it? We use it to decrease the resistance in the combination. Is that okay? Right. Now I want you to come to page number 184. There's a small question here. Can you see this circuit diagram? Okay. Sometimes the questions which are going to be asked in your papers are not going to be in the form of a word problem. You understand what I'm saying? Sometimes I give you only a diagram and ask you questions. Okay. So first of all, let's see how to interpret the diagrams that they have given so that we understand what needs to be picked up and what is asked. Or if you draw this rough diagram in your notebook so that it becomes easy for us to remember. I'm just drawing only this part. There is a 4 ohm resistor. Then there's a bulb. Okay. Then there's a battery, an ammeter, and of course there's a key. Finished? Just the rough diagram quickly. Now I want you to recognize what is being given. This you can just write down the page number or example number is 11.7 and we try to see how it is to be done. Page number 184. Right? Right. An electric lamp whose resistance is 20 ohm. Right? So here, this is what is given to us. Electric lamp is given 20 ohm and a conductor of 4 ohm resistor. So we can take this as R1 and there is another R which we can call it as R2. The resistance is given as 4 ohm. Are connected to a 6 volt battery. Okay, so your voltage or your potential difference of volt is 6 volt. Okay. Now what should we find out? We need to find the total resistance, okay, in the circuit. Then we need to find out the current through the circuit and the potential difference across the electric lamp and the conductor. First of all, we have to recognize whether it is in series or it is in parallel. Series? I think we are going to
It went off.
the generator must be on. Did you recognize that it is in series? Okay, you can take this as R1, you can take that as R2, it's perfectly alright. Okay, so what is the connection here? It is in series. Total R.
R equals to R.
Come on, do it. The first way. The first thing you have to find out, because we know it is in series, we know the formula RS is equal to R1 plus R2.
24.
That's what obviously we know. Come on, write down. Step by step, let's do. Next, what are we asking? They're asking you what is the current. Now, looking at the diagram, what can we find out? The current is flowing here. See? Flowing like this. Is it the same current which is flowing through each one of them?
Mark for the current and this, like it's from the battery, it's going towards the ammeter. It's in the figure.
What did they say?
Like the arrow is towards the ammeter.
That is the wrong thing. No?
Um,
They have given one like this, isn't it? They have given one like this. No, that's wrong. It's like this.
and the word fraction includes.
Yes, yes. Okay. How can we use the second one? How can we find out the current? Which formula will we use? Ohm's law. Okay. So by using Ohm's law, V is equal to I into R. I is equal to V upon R. We know how much it is. Okay. R we already know, we have already calculated it is 24 ohms. So V is 6 upon 24. Answer will be in what? What will be the unit for I? What is the unit for I? Ampere. Correct. Okay, because I is current and therefore the unit will be in ampere. So how much is that?
0.2.
1/4. 1/4. 0.25. Correct. So it's 0.25 ampere. So we have found out about current. Now they are asking you find out the potential difference across the electric lamp, that is across this, and also across the conductor. Electric lamp and the conductor we have to find out individually. Which formula shall we use? Once again we are going to use Ohm's law. Once again it is the same formula, V is equal to IR. So find out potential difference across. So you have got lamp A. For lamp you will find out. You will also find out across the conductor. So V here is equal to I. How much is I? 1/4, which is equal to 0.25 amperes, times the R, resistor. What is the of the bulb? How much have they given you? Lamp they have given as 20. Okay, so that's your 20. Find out the voltage. How much is that?
5.
Did you do it?
Yes.
5 what?
5.
Volt. Okay. Now do it for the conductor, the same thing. V is equal to 0.25 ampere times,
4.
here it is 4. Okay. So it is 4 ohm. So 4 times 0.25, it is equal to 1. Is your answer correct or not?
Yes, sir.
How did you cross check? With the textbook? It's there, correct. But how do you check? Suppose such a type of a sum comes. Did you notice here?
5 plus 1.
Yes, did you notice here? ये क्या है?
6.
5 plus 1. You understand? So the potential difference across this and potential V1, V is equal to V1 plus V2. Is it? Have you all that? Did you understand? Now look here. We have done all this. Correct? Could I take one? Could I take one? Right? So why I put up the diagram is maybe this information is not even given to you. Maybe it is given only in the form of a diagram and they'll ask you questions. So how can you interpret it? Is that okay? Suppose this part of
the
it.
total resistance.
Sorry.
Find the total resistance.
RS we have already found out. No? RS is equal to 20. We have done that. Is that okay? Suppose this is not given to us. Suppose they have just given you only this. R1 is also not given, this is given. Okay, with this information, will you be able to do it? Now, did you understand how it has to be done? Recognize first that these two are in series. RS is equal to R1 plus R2. Okay, find out the current by using Ohm's law, right? Use RS as 24, find out the current. Using current, you are going to individually find out what is the potential difference. Is that okay? Got it? Okay. Now I want you to read from here. Suppose, now the same problem that they have spoken about. Toshitani, suppose.
Suppose that we like to replace the series combination of electric lamp and conductor by a single and equivalent resistor. Its resistance must be such that a potential difference of 6 volt across the battery terminals will cause a current of 0.25 ampere in the circuit. The resistance R of this equivalent resistor would be R is equal to V by I. is equal to 6 volt by 0.25 ampere is equal to 24 ohms.
What does it mean? Suppose we don't have two of them. We have taken R1 and R2. Suppose these two are not there. What should be the total resistance if we want a current of 0.25? Obviously, it is going to be 24. So they have back calculated and shown you how it has to be done. Is that okay? That is not essential for you to do. What is essential is only this part of it is how it has to be worked out. Is that clear? Right. Next, in-text questions. Who will read? Anish will read?
Draw
Schematic.
schematic diagram of a circuit consisting of a battery of 3 cells of 2 voltage each, a 5 ohm resistor and 8 ohm resistor, and a 12 ohm resistor and a plug key, all connected in series.
Will you be able to do that? Quickly, within 2 minutes. How many resistors do we have?
3
How are they connected? In
series.
series. Write down the value for each one of them. What is the voltage?
2
Read properly. Is it 2?
Yes.
Is it 2? 2 each.
each.
Okay. So you will draw, you will not write it directly, write it as 6. You have to show 2 3 times. Did you understand? How will you write? It's like this. That's 1, that's 2, and that's 3. Correct? So obviously the total voltage will be 6. Quick. 2 minutes, that's all. It's a battery of cells. I've drawn for you. Show the ammeter. Quick. Series, you have drawn parallel. See? Wrap it up. Series. Hurry up. It should not take much time. Draw the ammeter. Okay. What else is given to us? Put the values of each one of them, right? 5 ohm resistor, 8, 12. If you draw your plug key, is there a plug key? And your battery, the way you have drawn is totally wrong. You have drawn only the positive terminals. Where is the negative terminal? Like this, you should draw. Another one there. You should say a positive and a negative. Then put a plus and minus, otherwise no marks will be given for that. Correct. Put the arrow. This is V. Rub it up. Okay, right. For battery cell, you put plus and minus. How many have you taken? Only 2? How many? Yeah. Right. Please the question. Battery cell. Yes, I have to on each side. On correct. Put the arrows. See, children, you will lose out if you don't show all these details. Show arrow. Okay. Yeah. No, this way is wrong. Plus and minus. How many will you draw? See how many mistakes you are making. No. When you are putting it in series, you should put it this way and this way, not on this side. Here, like this. Put a plus there, so a minus there. Yes, that is right. Plus this one? Sure. Correct. You are almost done, but then you write Show your voltmeter. What is the slide here?
Orbital.
Where is your V? If you want to put a voltmeter, you have to put a voltmeter. Put a plus and minus. Sure. No, it's not necessary. But if I'm asking you to draw, then. Come here. Sir.
Arrows are considered.
Okay. So you realize, please pay attention, things that you must be careful about. This, right? Your positive terminal and negative terminal. Sometimes children just draw like this. This is again wrong. Pay attention because I'm telling you what are the points that you should look for. These are very easy things where you can get full marks. But if something goes wrong, they'll totally cut it out. Okay, so in the examinations, we don't consider any wrong diagram at all. So that's why this is the first thing that you should remember. Second thing, show these arrows. Okay, very important. Next, when you're drawing the resistors, whether it is in series or parallel, plus your value, whether it is 2 ohm, 5 ohm, 10 ohm, that also has to be indicated. Okay, if there's nothing, then you write it down as R1, R2. Have you all written R1 and R2? I've written, look at it. Next, key. Make sure that the key is closed. If it is open, then the current will not flow. Did you see that? This is an open key. Okay, if open key is there, obviously the connection is not correct. Then of course, ammeter. You can draw the ammeter here, you can also draw it here anywhere in the series. Okay, now let's read the next question. It is based on the first question. Read.
Draw the